Okay, so numeric data types. So data types. We've seen a couple of data types already, but let's talk a little bit more about what they are, right? So we saw some expressions. 3 plus 4 yields 7, and then 3.14 minus 1 would give us something like 2.14. Both of those are numbers, but both of those are actually very different numbers. And so these numbers, and we have two different types of numbers here. This first number is what we call an int, which is short for integer. And that makes up numbers like 42, 100, minus 20, 0, nothing with a decimal point. The second number over here is what we call a float, which is short for a floating point number. And so that's going to be something like 3.14, 2.71, 9.8, negative 1.2, technically 0.0 is a floating point number. So why does this matter? Why do we have two types of numbers in Python? And this is actually a pretty normal programming, not just Python. And remember, if we were to divide something like 5 divided by 2, we're going to get 2.5, right? And then when we used, and by the way, those are two integers. That's an integer divided by an integer, but it still results in a floating point number. Whereas we do 5 double slash divided by 2, we're going to get 2 using the floor division. We already talked about what the floor division was. That's basically where we drop the decimal point. And so one of these yielded a floating point number, and the other one yielded an integer number, int. And again, an integer is just a whole number. What about these two? Right? There's no decimal or remainder or anything. Both have the value of 2. But in Python, this one is 2 without a decimal, but this one is actually 2.0. So when doing regular division, we always get a floating point number. And so this ends up being a float and an int. Just like these are floats and ints. Always get a floating point number when we use the regular division. And so if we think about our data types, right, we have two types of data at the moment. We have integers and we have float, and they have different purposes. And knowing how these two types helps, though, when you're just doing numbers. And let's look at idle, because there's some things we could figure out in idle. So just doing that example we just did, just to make sure you see the 2.0 and the 2 at the bottom left there. Use some other numbers, 1, 3, 1 divided by 3. So we get the regular division, we get the floor division. Really, it's just the integer part of the quotient, right? And then let's look at 3 times 4. 5 divided by 2 minus 1. What do you think we're going to get there? Let me fix my spaces. And if we look at that one, we can also look at the other version of it with the floor. 5 divided by 2. Well, first we do this, right? This is 12. This is 2.5. So 1.5, 13.5. But if we do the same thing again with the floor division, now we're going to get 12 plus 5 divided by 2 is only 2. 2 minus 1 is 1. 1 plus 12 is 13. So we get an integer only number. But let's think about, we did something earlier. We did 10 divided by 3. We got this little weird rounding thing right here. And you don't exactly know where it's going to round, do you? You get different things that's happening. I mean, we can do all of them, 8. But notice the rounding. Isn't technically 1/3 of something an infinite number of 0.3s? The answer to that is actually yes in math, but a computer can't store an infinite amount of data. You'd run out of memory, you'd run out of disk space. So it has to round somewhere. And again, we're not going to get into the details, but what really it means is that floating point numbers have this built-in inaccuracy, and they're hard to compare. And sometimes it's not even needed. Sometimes you just need integers. If you're counting from 1 to 10, do you need to do that in decimal points, or do you just need to do that in integers? And then there's going to be some other things that we're eventually going to look at where you must use integers. And then remember modulo. So we have modulo is always going to return a remainder, but remember modulo is actually an integer operation. Like a floor, a modulo is an integer operation. It's always going to return an integer. And because of that, we can use the modulo and the floor to manipulate integers, which again are whole numbers. And it allows us to do things like, if you want a fraction, numerator and denominator kind of thing, you use integers for each number. And so we use them, we separate them out, and they have different purposes. If you're dealing with money, that's a floating point number. You don't really, I don't know about you, but I like my pennies. And I want people to keep giving me my pennies. It happened at the beginning of the pandemic, right? You went to Chipotle and you gave them cash and they ran out of coins. And so they didn't give you change. And people got upset, understandably so. Who wants to give away their money? Well, if you want that decimal, and banks love their decimals, you need to use a floating point number. But a floating point number isn't always needed. And so we have those two data types. And we're going to look at some more data types later. There's a lot of other data types.